Hey there, everyone. In today's teaching lesson, we're going to see how we can use TF-IDF and cosine similarity to match resumes to job opportunities. And as always, we're using Python and Jupyter notebooks. Okay. So what is TF-IDF? Text frequency and inverse document frequency are two terms. Hold on a second. Just notice a small typo. Two terms that help us understand how frequent a word appears in a document or a corpus of documents. A corpus can be a whole collection of documents. It could be 10, 20, 100. And inverse document frequency tells us how unique that word is across the document or across the corpus of documents. Again, it could be dozens, it could be many, it could be just one, right? So we want to see how frequent terms show up, and inverse to the number of documents that term shows up. So words like a, is, the, and, or are very common. That's going to show up in all the documents all over the place. But is that meaningful? No, that's not very meaningful. You want words that really represent some kind of purpose or some kind of meaning of the document. So the word apple, banana is probably not going to show up in every document that you're scanning through when you're doing some type of machine learning exercise. So those words have more meaning. Something like tractor or blue whale, right? These terms are less frequently used, so they have more meaning. And just with a couple of terms, you can get a sense of what the document is about. If you have a whole bunch of terms that say the, is, and, or, but, that's not adding any meaning to the document, right? You can't understand what the document's about just from those words. So we want to look at the TF-IDF vectorizer and the cosine similarity. This is going to help us understand how two vectors that occupy a multi-dimensional space are similar or dissimilar to each other, depending on the direction that these vectors point. Okay, so cosine similarity is used in a lot of text analysis exercises to gain information or to extract information from the document that you're analyzing. Now, let me give you a preliminary heads up. Normally, I do everything in sequential order here, but let me give you a little spoiler alert here. So we are looking at one job description and then a bunch of resumes that sit in a folder, and we're going to try to match how similar the resumes are to this job description. So I have here, I think I found this thing online. I didn't type this up myself. So you have Python developer responsibilities, including writing scalable code, so on and so forth. I have responsibilities as write effective, scalable code, develop backend components. That's what's highlighted here. To improve responsiveness and overall performance, integrate user-facing elements into applications. So I kind of cheated a little bit, and I put that exact same vernacular over here into Amy's resume, write effective code, develop backend components to improve responsiveness and overall performance. So I'm going to force this one to be a little bit higher ranking on the cosine similarity scales, just to illustrate the point of how this works, because it was kind of lazy. I just copied the resumes and changed a couple of words, but they're pretty much all the same except for this one. So you'll see how this one sticks out because it's most similar to the job description. And even though I'm kind of cheating here, basically what you want is the candidate's resume to kind of match the job description, right? That's exactly what you're looking for. You don't want something that's completely different or something that is very dissimilar. You want the resume to be very similar to the description of the responsibilities of the job. That's the whole point here, right? So we are going to use TF-IDF vectorizer and cosine similarity to automatically show us which resume is the best. I can tell you offhand, right, it's actually Amy, because I just showed you that. So we have the job description here. This is saved in my desktop. I have a whole bunch of resumes saved in this folder, also sitting on my desktop. It's called All Docs. So it's going to scan through all those PDF files, go ahead and extract useful information from each one, and it's going to start compiling all of those resume data points into this list called resumes, and then resume text. Okay, so a list is represented by square brackets. A tuple would be curly brackets, and a dictionary would have key value pairs, right? So you can tell this is a list. So we're going to take everything and append resume files into the resumes list. You can see it right here, resumes.append. So we're taking everything and basically appending or merging or pushing everything into that list. And then we have resume text also appending everything into that list. So I think I just ran it. I'll do it again. Just make sure, Control Enter. Okay, and then we have our final results. So this is going to be a pretty short video here, guys. Pretty simple, pretty short. Let me delete this. I think that was from an earlier run when I was looking at something. I don't really need that because we already have it printed out. Okay. I don't want to duplicate anything. So Amy's resume is the most similar based on the cosine similarity analysis, right? So we would call Amy anything that has a higher score. I would look at the top 3. We're looking at all of these right here. If you did something like, I think, 3, Control Enter. Oh, those are the bottom 3. Wait, let me do this. Sorry, these are the ones we don't want to call. Those are the bottom 3. Yeah, okay. So these are the top 3 resumes. These are the 3 people that we call for an interview because their resumes match the job description. So I'm not going to go into all the details of the code. Again, TF-IDF and cosine similarity come to the rescue here. They save you tons and tons of time scanning through all the resumes and a lot of headaches if you're a recruiter. You can dump all your resumes into a folder, scan through all of them, and match that to one specific job description. They call it JD, right? Job description. So you're matching everything to one thing. That's the one thing, and everything sits in here. You can have hundreds of resumes. It doesn't really matter. Python's pretty efficient. I'll scan through hundreds, and again, it picks the top 3 candidates. So you call this top 3, and you save yourself a bunch of time. So this is just one example for using TF-IDF cosine similarity. It has some other NLP examples that I made videos for, and I posted it online here. So I'm going to save all this code so you can copy paste it, run it as is. You don't have to worry about all the details and all the nuances here. Everything's done for you. I'm going to save this as a HTML file and then post it when I post the video. So again, you can run this in your own Jupyter Notebook environment and get similar results. And of course, I'm trying to make this just a generic example. So if you can think of ways to modify or enhance this business logic, by all means, go ahead and do so. I encourage you to experiment with this stuff and use it to your advantage, save yourself time, make your work more streamlined, make your results more accurate, whatever you need to do. Okay, so that's pretty much it. Short video, just like I promised. I'm gonna save this file and post it when I post the video. Hopefully you guys learned a couple of new tricks today. Thank you so much for your time. Have a wonderful day.